Hello, my name is David Elliott from AkzoNobel Decorative Paints. My poster is entitled The Importance of Particle Dispersions in Paint Formulations and the Need for Better Characterization Methods. Here for reference is my abstract to read later. I'll carry on with my presentation. Water-based paints with polymer latex binders are complex mixtures of different dispersed particles, which range widely in their size and shape. The particles are generally stabilized thermodynamically by anionic charges and steric interactions of bound polymer chains, and kinetically via the viscosity or the viscoelasticity of the continuous medium. Each of these particle dispersions has their own individual function in the product, and it is important that they are all kept stable. Since there are many potential interactions between the particles, this is a difficult task for the paint formulator with many challenges. And making paint colours accurately and robustly is one such challenge. Paint colours are generally made by mixing together white base paints with concentrated dispersions of coloured pigments called tinters. This can be done either on a large scale in the factory or on the small scale in a paint store. In addition to the tinter and the paint forming stable particle dispersions themselves, another requirement for an accurate mixed colour is that the coloured pigment particles and the particles in the paint form stable dispersions when the two components are mixed together. In the lab, this is tested using a finger rub-out test on the partially dried paint. The colour of the rubbed-out region can generally differ from the surrounding undisturbed regions in two directions. It can become more intense in colour, and this indicates that there's some flocculation of the coloured pigment. Or the rubbed out region can be whiter, less intense in colour than the surrounding area, indicating that there's some flocculation of the white pigment in the mixed paint. Several features of particle dispersions in paints make them difficult to characterise, but the high concentration is a particular challenge. Most available techniques involve high dilution factors, leading to doubts on whether the size distributions and quantities like zeta potential are representative of the real material. In my example, I show zeta potentials for a yellow pigment measured versus surfactant concentration. In the first case, using an electrophoretic light scattering instrument at 0.03 weight% concentration, and in the second case with an electroacoustic instrument at 5 weight% concentration. The agreement is quite good considering the differences in the techniques employed, but different conclusions could be drawn on the preferred surfactant and its required concentration from the two sets of data. And even with the electroacoustic measurement, the concentration of 5% is some way off the in-service concentration, typically of 50 to 60%.